User-defined functions, part 4. Last time we were looking at this code that worked with matrices. What the code did was read in a row and column, read in the matrix itself, printed the matrix, and then also summed a diagonal. Actually, it sums two diagonals, but we'll look at that in a sec. Okay, so we copied and pasted as is into Visual Studio. That's how we knew what the code did. We acted like the compiler just to double check that that's what we thought the code did. And then we looked at writing. We wrote a user-defined function to read the matrix, and we tested that code. So what we needed to do next was write a user-defined function to print, write a user-defined function to calculate. Okay, so let's look at the code from last time. We declared our user-defined function. Okay, compiler, we're writing our own function. We're going to declare how it works so that you know it's coming in a void. We're not going to return anything, so that's void. We're going to give it a name. We're going to call it by read matrix. We're going to send in these three parameters. Arguments will come out of int main void and get accepted by an argument called, a parameter called matrix, a parameter called row, and a parameter called column. So these are the three parameters that are going to be accepted from a call within int main void. This is our call within int main void. We called it by name. This argument array is going to be sent and stored into capital M matrix. This M, which is the row, is going to be sent in and stored in row, and is going to be accepted and sent into the variable column. Okay, so we declared our user-defined function, we called it, and then we have to define what it does, and that's what we were doing here. So this is our definition of the user-defined function. Okay, when we define our user-defined function, it has to match this exactly. So what I usually do is just copy and paste so it matches exactly. Instead of the semicolon, we've got the curly bracket, close curly bracket, and then why is this return and not return 0? We said we're not going to return anything. This is the return data type. Void tells us we're not going to return anything. We're just going to do this stuff and go back to where we call it not returning anything from the user-defined function. Okay, so let's see how this works. Enter the size of the matrix. So let's put in, say, a 2 by 2. We'll put in 10, 13, 2, and say 8. Okay, so the main diagonal goes this way. 10 plus 8 is 18. The off diagonal goes this way. 10 plus 8 is 18. 2 plus 13 is 15. Okay, so that's what we did last time. We want to add in a user-defined function to print and a user-defined function to sum the diagonal. Okay, so we got to give it a return type. Once the function is called, it finishes completely. What is it going to do after it finishes? Is it going to return an integer? Is it going to return a character? Is it going to return nothing? If it's going to return nothing, then we say void. we give it a name, and then we say what we're going to send to the user-defined function from int main void. We're going to send in the matrix, its row and column. Okay, so there's the declare. Now we're going to call it. So I'm going to say print matrix. Okay, it says, all right, this is how you declared it. Here's what I expect. A matrix, a row, and a column. Within int main void, our matrix is called array. Within int main void, our row was m, column n. So there's our call. Okay, so now we're going to take this code out, because that's going to be what our user-defined function does. So that's got to be in our definition. Okay, so I'm going to just kind of type this here just so that I've got it copy-pasted. It's important that the declaration statement matches exactly. It's important that the declaration statement exactly matches the definition opening header. Instead of the semicolon, we have the curly bracket. What did we say we were going to return? That's void, so nothing. So we're going to end this with just return. Okay, some red squigglies in here. Within the user-defined function, I have to have variables declared that are going to be used only within the user-defined function. For example, I can't be out in int main void. It has to be here in print matrix. So we've got to declare it. M, red curly bracket, because it's in int main void. It's not here in our user-defined function. I can only use variables that are local, a local variable, variables that are local to the user-defined function. So M would be called a row within the user-defined function. N would be called column within the user-defined function. I sent in matrix within the user-defined function. Okay, let's do a start without debugging. Let's go with a 3x3 this time, and then we'll put in 4, 5, 6, 7, 1, 3, 2, 6, 3, 8. Okay, so what did it do? It read in using our user-defined function. It printed using our user-defined function. Int main void still has the main diagonal. 6 plus 1 is 7 plus 6 is 13. And then our off, this is the main diagonal. 4 plus 1, which is 5, 8 is 13. The main diagonal is this way. Off diagonal is the up part. 6, 1, 6. And that happened to be 13 again. Okay, so one last user-defined function. Now we have this done. We need this one, the user-defined function to calculate the sum. Okay, so user-defined functions, 3 things. We declare, we call, and we define. Okay, so we'll start with our declare. Void sum diagonal, or whatever you want to call it. And I'm going to go ahead and send in the matrix that I want to sum those diagonals. Okay, then we're going to call our matrix. So that's going to be sum diagonal. There it is. I'm going to send it in the same thing. I'm going to send it in, like I said I would, an array, a row, and a column representation. So that in here would be array, m, and n. These are variables that are within int main void. So I have to use variables that are local to int main void. Okay, we grab this heading and we create our user-defined function definition. Void means we're just returning. To stop the program, we're not going to return any integers or anything like that. We're just going to return. Okay, so let's see, where are we? Here's where we're summing the diagonal. So let's go ahead and put that inside of here. We expect to see some red squigglies because things were defined differently. Okay, so we need int I, we need int sum, and we're going to set it equal to 0. We need int a, and we're going to set it equal to 0. Those are here, the sum and the a. So I want to set those to 0. Okay, so we sent in matrix, not array. We have row instead of m. We have row instead of m. I don't think I see any more red squiggly, so I think that we're good. Okay, so let's see. Let's just do a quick. We start the program. We ask the user for the row and column. We send that matrix with the row and column just read to our user-defined function for reading. It comes back when it's done, and we send it to printing. It comes back when it's done, and then we're going to send it to diagonal. Once diagonal gets completed, it comes back, prints if the sizes rows don't equal the columns, otherwise ends the program. Okay, so let's see how this looks. A little too fast in my typing. Unreferenced variable I. That is in line 17. Okay, so it's telling us in int main void we're never using I. So I need to get rid of it. Nor j. So I'm going to get rid of it. In int main void we're never using a or sum. Within int main void, these are the only variables that we're making use of. Okay, let's try again. All right, let's check it out. Okay, so what does it say? Array is an undeclared identifier in line 80. Okay, that should be matrix, because that array is in int main void. Matrix is in the user-defined function. Okay, I think that should be good, but let's check. Yay. Okay, so let's try a 5 by 5. We'll put in maybe 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 2, 1, 8, 7, 6, 4, 3, 2. Okay, so the main diagonal would be 6 plus 1, which is 7, plus 5 is 12. 13 plus 7 should be 20. That's your off diagonal, 20. And then your main diagonal goes this way. Main diagonal, 9 and 3 is 12, plus 5 is 17, plus 8 is 25, plus 2 is 27. Okay, so in case I said it wrong the other way, This is the main diagonal, 27. The off diagonal is 20. And that's it.